So this week's lesson is reviewing all of the ways that we've learned to factor. So have a pencil ready and be ready to take some notes. Just if you've gone over each of the last lessons that I've provided for you, then you should know these ways of factoring. But we're just going to quickly review these ways before we head into spring break, and then after spring break we'll see what we need to do to review this as well and continue on. So today I'm going to go over a flow chart. That flow chart is going to be attached on Canvas so that you can download that and look at it if you need to, but that kind of helps us think through our 4 ways of factoring. And then we're going to take a look at some problems and just try to think if we know which method to use in order to factor. And then I will go through some examples to help you remember how to use those factoring methods, and then I will explain the practice that I want you to do for this. So not only do I want you to be able to factor any polynomial using greatest common factor, grouping, DOS, or guess and check, but I also want you to be able to determine which method to use when you're looking at a given polynomial. So here's the flow chart that you will find on Canvas. So remember, we first always look for that greatest common factor. Okay, there can be 2 terms, it can be 3 terms, 4 terms, however many terms, but if they all have something in common, then you want to use that greatest common factor method and factor that out. Okay, now if it doesn't have a greatest common factor, if there are 2 terms, then you'll want to use that difference of squares method, which remember is that whole concept is like taking the square root of all of this and getting those parentheses. Okay, they match, but one sign is positive and one sign is negative. Okay, if it doesn't have a greatest common factor and there are 3 terms, we're going to use that guess and check method, which remember we are setting up those 2 parentheses, but it has to do with the factors of that last number and if there is anything out front. Okay, so I'll go over that later. And then if it doesn't have a GCF and it has 4 terms, we are going to use that grouping method where we split that in half and then find those GCFs within those problems. Okay, so let's go ahead and take a look here at a few problems just to kind of think through which method we would use. So I'm taking a look here at 2b squared minus 8b plus 6. I notice that they don't all have b's, so they don't have that in common. Remember, I'm always going to check for that greatest common factor first. Okay, but if I look at the 2, the 8, and the 6, I see that they're all even, so I know that they at least have 2 in common. So yes, I would use that GCF method on that problem. Okay, let's take a look at this one. Again, I am going to check for that greatest common factor. I have 4k squared minus 25. They do not have k's in common, and the factors of 4 are 1 and 4 and 2 and 2. Those numbers, except for 1, remember 1 doesn't matter. They do not go into 25. So I now have to think, okay, it is not GCF. So the question is, which one is it? Well, when I look at this, it has 2 terms. So it's going to be that difference of squares, remember, where we would take the square root of those things. Okay, another one here. 2n squared minus n minus 6. Again, I'm going to look for that greatest common factor. I see that they don't all have n's. This one has a 2, this one has a 1, this one has a 6. So let's see, if this has a 1, then the only thing I have in common is a 1, which doesn't change anything. So they do not have a greatest common factor. So there's no greatest common factor here. So the question is, which method? Well, I see that there are 3 terms, so that's going to be that guess and check. So we would use the guess and check method for this problem. Okay, taking a look at another one here, 32n squared minus 50. I see that they don't have n's in common, so looking for that GCF. You know, I immediately am thinking like DOS when I see that because there are 2 terms, but I can't find the square root of 32 and 50 and get perfect numbers. So there must be a greatest common factor there, and I know they're both even, so I know that they have 2 in common, and so yes, this is GCF. and I noticed that they don't all have ends, so I can't factor ends out. 6, 10, 3, and 5. The lowest number 3 there, the factors are 1 and 3 doesn't go into 10 or 5. So in looking at the GCF here, there is no GCF, so it's no GCF, okay? And if I look down here, 2, 3, or 4 terms, there are 4 terms, so that is going to be grouping, okay? So I'm not going to be solving these and actually factor them out, but if you take a look here, it says write which method needs to be used in order to factor the given polynomial. Okay, it does say then factor, but I'm not going to do that. We're just going to take a look at actually what method it is. I would encourage you to pause the video and see if you can jot down which method you think you would use for these 4. And then once you're done with that, go ahead and play the video and I will go through the answers. There will be several slides of these, so you'll have some opportunities to pause the video and try these and then continue on. So on number 1 here, again, looking for that GCF first. They do not all have V's, and the lowest number there is a 1 out front, so the only factors are 1. And so that's not going to change the problem if I factor out that 1. So this is not GCF, and if there were 3 terms, remember that was guess and check. So this one is guess and check. Okay, moving on to number 2. They do not all have V's. Let's see, looking at 28, 20, 21, and 15. Again, if I look at the smallest number, that kind of helps me get there a little bit faster. So for 15, 1 and 15, and 3 and 5. 3 does go into 21, but it doesn't go into the others. 5 goes into 20, but it doesn't go into the others. So there are 4 terms here, and so I want to use grouping. It did not have a GCF. Okay, number 3, looking at the GCF here, they do all have X's, so I know immediately that they have something in common there. So this is using the greatest common factor method. Number 4, they do not have X's in common. And when I look at that, 1 would be the number they have in common, which if I divide that by that, it doesn't change the problem. So now it looks like I have 2 terms, and remember, I can find the square root of 16 and 1 and get whole numbers. So this is difference of squares. All right, if you'd like to pause again before I go over these answers, please do so now, and then start it again. Number 5, looking for a GCF. They do not both have X's. 25 and 9 only have a common factor of 1, so dividing by that isn't going to change the problem. So when I look at that, I have 2 terms, DOS, and yes, 25 and 9 are perfect squares, so I can use DOS for this problem. Remember, you only want them to be those perfect squares. If they're not, then you can't use DOS. Number 6, they do not all have ends in common. When I look at 30, 42, 25, and 35, the factors of 25 are 1 and 25 and 5 and 5. 5 goes into 30 and 35, but not 42. So I cannot use GCF, and there are 4 terms, so that means I'm going to use grouping on that one. Number 7, they do not all have P's, so I know that they don't have that in common. Looking at 18, 20, and 20, 18 would be the smaller number there, so 1 and 18, 2 and 9, 3 and 6, 2 does go into 20, so I would use GCF here. They have something in common. Number 8, they both have a P that they would share, so that one is also greatest common factor. Okay, again, if you would like to pause the video and jot down your answers for which method you feel like you would use, please do so now. Number 9, looking at that, they both do have X's there, so that I would use greatest common factor there on number 9. Number 10, looking at, they both do not have X's, and the number that they have in common is 1, so that wouldn't change the problem if I divided by that. And I can take the square root. Remember, when there's two terms, I'm going to use DOS. So, and that's only if there's subtraction and I can find the perfect square root. So I can do that for, remember, this is a 1 and 16. So I would use DOS for that problem. Number 11, they do not all have m's. The number they would have in common would be 1, so that doesn't change my problem. There are 3 terms, so that's going to be that guess and check method. Okay, number 12, they both have p's, so I know that that's going to be the greatest common factor method. Number 13, they do not all have the r's. When I look at 63, 27, and 54, 9 does go into all of those, so this is going to be greatest common factor. Number 14, 21r cubed plus 49r plus 35, so they don't all have r's. And 7 does go into all of them, so that would also be GCF. All right, so at this point, hopefully you can kind of think about which method to use, but I'm going to go ahead and review a few problems here to remind you how to use those different methods as you do need to factor some problems in the practice. So on this one here, looking at n squared minus 4n minus 32, they do not all have n's, and the number they have in common would be 1. So again, if I would divide by that, it doesn't change it. So no, this does not have the GCF. So I'll then say, okay, there are 3 terms, and so that is that guess and check method. So I'm going to want to factor this into 2 sets of parentheses. And if you remember on our guess and check, I need an n and an n here, so that when I multiply, I get n squared. There's a 1 there, so that's nice. But now I want to look at those factors of 32 that help me get to 4. So 1 and 32, 2 and 16, 4 and 8. Oh, right there it is, 4 and 8. They give me 4. So if I put 4 and 8 here, I need a negative 4, which means I need a negative 8 and a positive 4. So that will give me that negative 8n, positive 4n, and then negative 32 if I were to distribute all of that out. So there is that answer for number 1. Okay, looking at number 2 here, they do not all have v's in common, and the number that they would have in common is 1, so that wouldn't change my problem. So no, there's no GCF. There are 4 terms, so that means I'm going to be using grouping. So remember, with grouping, you're going to split that problem in half. And now I'm still using that GCF concept on each side. So here on the front, they have 3v squared in common. If I divide by 3v squared, I get v minus 1. Over here, they have a 2 in common, so I'm going to divide by 2 everywhere, and I get v minus 1. Again, with my problem, notice my parentheses match. So these 2 terms still have a greatest common factor, so I'm going to factor that out. V minus 1 is what they have in common. And when I divide by that on both of those terms, I have 3v squared plus 2 left. So that is that final answer. Moving on to number 3 here. Again, always looking for GCF first. So when I look at that, they do not have b's in common, and the number they would have in common is 1 again. And if I divide by 1, that doesn't change anything. So no, this is not GCF. There are 3 terms, so remember that is guess and check. So I am going to split it into my 2 parentheses. Notice this time we have that front number. So in order to get 3b squared, the factors of 3 are 1 and 3. So I'm going to have a b and a 3b. And now I still want to look at those factors of 4. So 1 and 4 and 2 and 2. But now remember, I'm using 1 and 3 here, so I have to know which one of these sets goes together to combine to get me that negative 1 in the middle. So like 1 times 1 is 1. 3 times 4 is 12. Well, 12 and 1 aren't going to give me that 1. Okay, 1 times 2 is 2, 3 times 2 is 6, 2 and 6 aren't going to combine to give me 1. Okay, but if I do 1 times 4, that's 4, and 3 times 1, that's 3. 4 and 3, they can give me that 1. So I know that I'm going to want a negative 4 since there is a negative here in the middle and a positive 1. Okay, so, and I do not want the 4 to be multiplied by the 3, so that means it has to go with the 3. So minus 4 and positive 1. And again, if I distribute that, I get 3b squared minus 4b plus 3b minus 4. And that middle does combine to negative b. So again, you can always distribute that back out to see if you got the original problem, but here is my final answer. Okay, problem number 4. Looking at that, they don't have a b in common, and 16 and 25, the only number that they share would be 1, so I can't, like, that doesn't change the problem if I divide by that, so I cannot use GCF. So there's no GCF, and there are two terms here. They are both perfect square roots, so I'm going to use difference of squares. So I'm still making those two parentheses, and now I want to take the square root of those. So like the square root of 16 is 4, so I put that in both parentheses. The square root of b squared is b, so put that in both parentheses. 1 is minus and 1 is plus, and then the square root of 25 is 5. And again, if you just distribute that back out, those middle terms are going to cancel out because it's a positive 20b and a negative 20b. And so that's why we only had two terms there. So there is the final answer. Okay, and last one here, number 5, looking for the GCF. They do not have any x's in common, and the only number they have in common is a 1, so there's no GCF. There are 3 terms, so I'm going to use that guess and check again. So again, splitting into two parentheses. This time I only have a 1 in front, so I just need an x and an x. And now I want those factors of 40, okay, that get me to 6. And there they are, 4 and 10. Okay, so I know I want a negative 10 and a positive 4 to make negative 6. So negative 10, positive 4, and when I distribute that back out, I get x squared plus 4x minus 10x minus 40. And those middle terms do combine to give me negative 6x. So x squared minus 6x minus 40 is my original problem. So here's my final answer. All right, so hopefully that kind of reviews for you those 4 types that we learned. The practice that is required for you, which will be for a grade, is a Canvas quiz. So make sure you're finding period 6, e-learning week of March 30th, mixed factoring. Remember that you can do that as many times as you need in order to get whatever grade you want. And if you have not completed some of the previous Canvas quizzes or Khan Academy work, please make sure that you are doing that so you're caught up, so that after spring break when we come back for new work, you won't have to get caught back up on that. There is also an optional practice worksheet on Canvas with some more problems and their answers provided so that you can check your work if you feel like you're kind of still struggling to make sure you know which method to use. So please email me if you feel like you need help, and stay safe and healthy, and please make sure that you are still staying in touch with your friends. There's still a few of you that haven't done your work, so if there's somebody in class that you talk to normally and you haven't been in contact with them, maybe think about texting them or emailing them and see how they're doing. All right, have a great spring break.